Okay, welcome back. So, we want to. You have a function that takes two-dimensional integer vectors to R, and it's additive on orthogonal vectors. Is the condition, and final. Yeah, so f0 equals 0, of course. And also, more importantly, just like f of a comma 0, a comma b is equal to f of a comma 0 plus f of 0 comma b right away. So you really only need to think about vectors that have 1, 0 component, I guess. I should use a and b, that's super confusing. xy, we'll use xy. So you can almost think of it as like you have two real valued function. Like it's like, okay, well, what do I know? This. I'm just gonna write. I'm gonna drop the parentheses because it's a little too pedantic. We'll just write f of like x comma y for. So you can get it down to like a one variable, like a pair of one variable functions right away. And then what do I do? Oh, okay, also, first of all, what the heck is the solution? I can see the 0 function works. I think... What would the solution be? Does projection onto the x-coordinate work? Like if I have a rectangle... Oh, projection onto the x-coordinate just... Actually, that's a bad sign. If that works, then projection onto any axis will work, right? Wait, hang on. That doesn't even require the perpendicularity, though. Oh, hell, hold up. Okay, so for any fixed vector, the dot product against that vector just works, like, period. Yeah, anything linear works. Okay, fine. There's gotta be more, right? Is there more than that? I feel like perpendicularity is it's a really strong condition, right? Is x squared plus y squared a valid solution? There you go. Yeah, I was like, there should be more conditions because linear works and oh god, absolute value works. Okay. Yeah, that would do it. Solutions. Answers: x, y, and x squared plus y squared for all solutions. Also, the set of solutions is a real vector space. Okay, I think I know. I have an idea where this is going. Yeah. So... Okay, so, assumption by shifting well, we should shift something, right? Because right now there's way too many parameters. By shifting Assume f of 1, 0 and minus 1, 0. Huh? Here's a question. How many vectors, like, how many f values do I need to pick before I can get everything else? Because like f of 1... Yeah, I'm so confused. There's something like the Euclidean algorithm. Yes, very much so. The keywords you're looking for are GL2Z. But it's like, what? How do I get more vectors in terms of other ones? Like, I can do f of 1 comma minus 1. I'm gonna take like any, just some rotation. F of 1, 1. These are perpendicular, right? Because they're dot product 0. So this is equal to f of 2 comma 0. I like this assumption that f10 is f of minus 10. And we can make it symmetric, I think. So then I don't have to deal with crap like... So it's like 2f of 1, 0 plus f0 minus 1 plus f of 0, 1. So if you know 1 comma 0 and 0... If you know like the four dots next to the origin, you can get 2, 0. And I'm willing to bet you can get everything actually, just from using this. Here, what if I just write n? Anyone, we're okay if we write n? Oh no, n, 1, n equals f. N plus 1, n minus 1. Right. And then here I have to... just complex it. Yeah, Gaussian integers is alright. But yeah, the point is like once you have this happens, right? And then similarly for others. So this is a recursion. It tells me that as soon as I know the values at for up to n, I can get the values at n plus 1. So now the question is whether I missed the solution. Because I would love to like shift so that like this is 1 and then this is 1 and then show by induction that these are squares. But right now I have 3 answers and 4 parameters. So Can someone give? Is there one more solution? Or am I supposed to find? I either need to find one more relation or one more solution. So, you can scale each direction independently. X squared plus CY squared? Are you serious? Wait, does X squared just work? Oh, of course X squared works. What am I talking about? No, wait, does it? Hang on. Hang on, one moment. I don't think does X squared work? I don't think it does. No, it doesn't. Oh yeah, okay, also that, yeah. I should just fight, right? I can... I should just fight it. All right, let's fight this. What we're gonna do is we're gonna pick the scaling assumption. We're gonna set the x thing to 1 and the y thing to like some constant k. So I have three degrees of freedom, so I should be able to shift this way. And we're going to see either I will find this marvelous solution as a function of k, or I will find some extra dependence on chi that will, if all goes well, force k equals 1. We'll find out. Okay, so let's crank out some stuff. So f of 2, 0 then is equal to what? So here, when I plug in n equals 1, I get 1, 0, which is 1, 0 minus 1 is k, 1, 0 is 1, and 0, 1 is another copy of k. Meanwhile, f of 0, 2, if I flip the same logic... I need to be careful here. I guess for the base case it doesn't matter. It'll be like k plus 1 plus k... 2k plus 2. Okay, and then f of 3, it's like... It will be symmetric, right? If all the previous things were symmetric, then by induction, so is the next thing question mark? Oh, but the... No, hang on, something's weird. Okay, I'm just gonna... I'm gonna write the analogous one on the other side so I don't get bitten by it. Someone stop me when I make a mistake. Why can't you just assume that? You shift f by a suitable linear combination of x, y, and x squared plus y squared, which I haven't worked out yet because I think there's a good chance that there will actually be a fourth family, like a fourth linearly independent solution, in which case, you know, it will be... I'll end up having to redo this k equals 1 anyways. I haven't worked out what the transformation is yet, although, I mean, they're linearly independent, so it's got to exist. You don't think there's an extra? Okay, all right, we'll find out soon. Oh, actually, here, I have a button I can press. Fuck. Hang on. No! Come back! Got it. Okay, did I do anything? Wait, help. How do you use this? Place your bets! Everyone thinks... Oh, is there... Okay, everyone thinks there's just 3. That's gonna be really boring. What happens to the poll if everyone votes on the same thing? I don't actually know. Interesting. Okay, some people might get very rich shortly. We'll find out. All right, back to our regularly scheduled programming. Okay, f of 30 is 2, 0, which is 2k plus 2, plus a k, plus a 1, plus 0, comma 2, which is also 2k plus 2, and then minus 1, 0, comma 1, which is k. Meanwhile, f of 303 is plus 1 plus k plus both the 2's, but the difference is this one is minus 1 and not minus k. Right? I hope. Let's find out. So this is equal to 5k plus 4, and this is equal to... No. This is 4k plus 5, and this one's 5k plus 4. Which, when k equals 1, still are both solutions. Okay, can I just compare 2, 3, and like 3 minus 2 at this point? Like, so in theory, shit, that requires a big number. Oh, come on. I don't want to go all the way up to 5. Holy crap. Whatever. Okay, let's. Oh, you gotta do what you gotta do. All right. Actually, 4 might be good enough. Hang on. Because there's a couple ways you can get 4. Like, one is if you keep pumping this recursion. F of 4, 0 is 4k plus 5. So, thing, and then a k, a 1, and F03, which is 5k plus 4. And then minus F of 0, comma 2, which is 2k plus 2. 9, 10, 10k. Hey, sorry, 8k plus 8. No, okay, we'll just keep going. It's also 8 plus 8. Is this the same thing you get if you do like this argument but with a bunch of 2s? I think it is. Yeah, 8k plus 8 is correct. So okay, we'll get to 5, all right? And I think after that we can get one more relation. F of 5, comma 0 is 4, 0, which is 8k plus 8, plus a 1, plus a k. Plus a k plus 1. And then an f of 0, comma 5, 0, comma 4, which is, yes, 8k plus 8. Minus f of 0, comma 3, which is 5k plus 4. Okay, plus 13. Okay, so what do f21 and f of... Oh, wait, is 2, 1 good and minus 1, 2 good enough? I thought that we kind of used up all the stuff that only had 1s. Wait, does 2, 1 and minus 1, comma 2 work? Echo, stop. Oh, echo is fine. 1 plus minus I, 2i. Seriously? Oh, I just assumed that I used up every equation that used a 1, so I was looking for the smallest equation that didn't have 1s in it. Okay, but the claim is that 2, 1, and minus 1, comma 2 is good enough. And the same thing rotated. Oh my god, equations. So many equations. And the same one rotated 90. Is that... Oh god, I can't keep up. Minus 1, comma 2. Minus 1 we agreed is 1 plus 2k plus 2. Oh, I see. Okay. Fine. Alright, yeah. Alright, good game. 1 plus... No, wait, you get 5k plus... No, that's not right. I feel like we used up everything that had a 1 in it. Do we not? One plus minus I, 2i? Yeah, slow down. You get 1 plus 5k plus 4, right? It's like 5k plus 5, and then... Hang on. Am I crazy? I feel like you don't... I feel like you just get the... Right? One, one, and 1 minus 1 gave you 2, 0. 2k plus 2 plus k. Oh, freaking. Okay, yeah, okay, I can see. Okay, yeah, alright, cool, very good. Okay, and then you do it the other way to get, what's the 90-degree rotation of this? It's like, we want to get 1, 3, 1. So we do like 2, 1, and 2 minus 1. And then 2 here, and 1 here. Sorry, the k here. No, hang on. Plus f of 3, 1, but the point is that 3, 1 will give you 4k plus 5 plus 1. Okay, I was wrong. I thought we just used up all the, Okay, very good. No, this should be fine, right? Are we good? I hope. Maybe. We'll find out. Yeah. Then you induction just carries it through. Should be 4k plus 5 plus k. Fuck. Oh, rip. I mean, I shouldn't be complaining because this is what I said would happen, but also, fuck. Shit, man. I just feel like because of the way we set this up, there's no distinction between plus and minus. And also, like, I wrote all the... Like, these... You will not get more equations out of setting one of the variables to 1 is what I claim. I think. Not in this way, anyways. Like, these are the equations for 1, so you cannot squeeze more information out of them, so to speak. I think. I'm not... I'm getting a little confused, but I think that's what's happening, is that we already used up all the 1. That's why I wanted to push to 5, because I was like, I don't think you get new information by plugging in 1s. Okay, minus 1 comma 6 2 perp 6 3 maybe we'll do something. However, that requires you to go up to 6, which is a big number. I was just going to do like f of 2 3 plus f of 3 minus 2 or something and call it a day. Because this is f of 5 comma 1. Which is 2k plus 2 plus 5k plus 4 plus 3 is 4k plus 5, and f of minus 2 should still be 2k plus 2 because everything's symmetric. And then f of 5 comma 1 is what we saw. F of 5 comma 1 is 12k plus 13 plus k. So now the great question is, does this work? And naturally we get 13 on both sides. All right, beautiful. Yeah. X mod 2 minus y mod 2. Does that work? Does that work? Can someone check? Shit, how do you check this? Yeah, but that means I have to do cases. Alright, cool, it works. Told you there's one more. What can I say? Yeah, so good job to the 1% this time. For the successful bet, winning 9,000 channel points because someone bet like many thousand channel points. There were only 3 solutions. Yeah, exactly. It's just like come on, like there's 9,000 channel points on the other side. You really think like 99% of the time there will only be 3 solutions? Uh, well, okay, I think it's basically well, I don't know. I don't actually. I think someone just bet too many channel points on 3 solutions too early on, and so probably we couldn't get the percentage for 4 solutions higher even if we really wanted to. Yeah, this is essentially me giving my points away. Yes, that is basically what happened. Uh, yeah. Yeah, I was just like, come on. I think I'm not allowed to bet because I have infinity channel points, but I think I always bet on 4. Because, like, the fact that the problem got suggested to the stream is, like, you know, should nudge you that direction. Do you know what SGF AMM I should put this under? Why is it called meow.py? I don't know, I just picked the file name. How are we done? Because we found 4 linearly independent solutions, and this recursion implies that 4 initial values are enough to populate the entire function. Did you solve the Uzbekistan? Yes. The other thing that bugged me, I think, was the fact that it was specifically integer lattices, because, like, I mean, the integer lets you do the induction, sure, but, like, x, y, and x squared plus y squared all don't rely on x and y being integers. Oh god, z cubed. I don't know if x mod 2 minus y mod 2 would give a solution. Or, like, linear independence? Oh, okay. It's not used there for verification. It's used later on when I comment that we found all solutions. Yeah, it's actually used in the other direction. I agree it's a little confusing to put it there. Yeah. Then by writing the analogous equations for negative numbers as well. Okay. It follows that the value of f is determined by these recursions as soon as the values of f0, 1, 0, f minus 1, 0. So this is why I didn't bother to work out the shift, is because I thought this might happen where we didn't even need to do it. The shift only mattered if the answer turned out to be dimension 3, and then I needed to say, okay, this is okay without loss of generality for the calculation. But because it's a 4-dimensional space, I don't even need to do that. It's like, like, if you know the value of f on those 4 points, it determines the entire function f, and ergo the space of valid f is at most 4-dimensional as needed. Yeah, ergo. Yeah, I think I first picked up ergo from like playing Phoenix Wright Ace Attorney. Okay, I want to attribute it to the person then, who, because there's no a in an issue number. I think this counts. Yeah, this counts as an FE actually. But this is the good kind of FE where like the solution is not just plug-in crap. It's like, oh, there's actually some conceptual reason coming on. You have to do something that isn't just a substitute. I mean, I guess we kind of only. I don't know. We got to use the words dimension of vector space. Okay, it's better than the average FE. Are you putting this in Monster? It's either Monster or Linalg. I'm actually a little undecided which one. It probably fits better in Monster, honestly. It's just like, I feel like Monster has like, this is going to be like the 4th or 5th problem in the Monsters unit where the solution is like exactly this shape, which is that you find enough solutions and then you find enough solutions and then you also bound it above using recursion. That's like why I solved it so quickly, is because I've seen this pattern in like 3 or 4 other problems, one of which I wrote on the UCMO in some year. But yeah, it probably does belong in Monsters. It's just that it's a little redundant, but it's fine. Is it possible there exists a set of initial conditions that cannot be written as a linear combination? That's true. Yeah, you could also throw this in the note. I'll probably look at the units and make up my mind later. Set of initial conditions. Yeah, so what I was saying earlier about not being able to shift. The short answer is that it depends on the function. Like, basically the reason that I was so confident the shifting would be okay was I was just like, well, I feel like the values at these 4 points are like not constrained, so it's fine. Whereas as a thought experiment, you can't shift so that f of 0 is 0 equals 1, for example, because every solution had f 0 equals 1. So there can be obstructions where you like, the functions are linearly independent, but like at the values that you're trying to do the shift by, they're not linearly independent, and so you die. That's the thing that can happen. But I was looking at the 3 solutions that we had, and I was just like, there's no way that happens. Like, the values are not closely related enough, I think, for us to run into a like particular point obstruction. As long as you stay away from 0, 0, because that point, we already showed that point is 0. Now let's see if AOPS can render the percent sign correctly. Important questions. All right, what a problem.